Generate 5 samples of 50 items in which the probability of occurrence is 0.4. Use the samples to create 5 80% confidence intervals. How many of your confidence intervals span 0.4? Okay, so I'm going to start by using a rand bin. And what I'm going to do is I'm going to have one trial. So it's actually a Bernoulli. Remember, a binomial is a series of Bernoulli trials. If I just have the one trial, it's a Bernoulli. And I'm going to say my probability of success is 0.4. And I'm going to generate 50 such trials. So what I then want to do is store those trials in a variable. So let's say that we store them in A. And you can see it's a series of Bernoulli trials, so they're either zeros or ones. We're going to have 50 of them there. And then what I'm going to do is work out the mean. And if it was, precisely modeling the population, then we would get 0.4, but it's unlikely that we'll actually get that. So let's go for the mean of A. So we're working out the mean of the 50 numbers above. And in this case, we got 0.42. Now we want an 80% confidence interval. So I'm going to go to inverse normal, center, probability 0.8, and that will give me the correct Z value. So my confidence interval is going to be the 0.42 take away my Z score multiplied by the standard deviation. So that is going to be the square root of 0.42 times 0.58, which is 1 take away 0.42, divided by 50, because there were 50 items there. And that's my 0.3305. And then obviously I want exactly the same thing, but I'm going to want a plus in there. And that's 0.509. So my first one is 0.331 up to 0.509, which does contain 0.4. Now, what we can then do is go back up here and regenerate. And this time I got 0.32. So I'm just going to go and need to edit these. So this one is 0.32. And that would make this one 0.68. And I need to do the same for the next one, 0.32 and 0.68. And I got, I didn't change the 0.42 there. So I need to change that to 32 as well. And that's 0.235 and 0.405. So 0.4 is included, but only just at this end. And I think from there you can see that it would only take a slight variation. Let's suppose that we got 0.31, and that would mean that we need to change in here as well. That would become 0.69, and same thing here, 0.31 and 0.69. And I think if we execute on those two, you can now see that I've got 0.226 and 0.394. That one would not contain 0.4. Now, obviously, the further you go away from 0.4, the lower the probability is. So it's not that probable that we're going to get 0.31 or less, or something that's much bigger at the other end. But for an 80% confidence interval, we'd be expecting it to not be in there 20% of the time. Now, I'm not going to go ahead and do the other three. You've seen how it's done, and you could always try this out for yourself.